May 26, 1944. Somewhere over Magdeburg, Germany. Oberst Johannes Steinhoff, commander of Jagdgeschwader 77 and a combat veteran with 176 confirmed aerial victories, pulled his Messerschmitt Bf 109G6 into a climbing turn and felt something break inside him that had nothing to do with mechanics. Through the armored glass of his canopy, stretching from horizon to horizon in a formation so vast it seemed to blot out the sky itself, flew over 200 American heavy bombers, escorted by 800 fighters. He had scrambled with every available aircraft in his Geschwader, 31 fighters flown by pilots who represented the finest fighter force ever trained. The mathematics were impossible. His entire fighter wing, at full strength with experienced pilots flying the most advanced production fighter in the Luftwaffe inventory, faced a bomber stream that contained more aircraft than Germany had built in the past 3 months. Steinhoff had read the intelligence reports describing American production as crude but numerous. Command assured him that German engineering quality would compensate for American quantity. Yet here, at 27,000 feet over the industrial heart of Germany, the sky was filled with American aircraft as far as his eyes could see. Boxes of B-17 Flying Fortresses and B-24 Liberators stacked in combat formation, their aluminum skin gleaming in the afternoon sun, each bomber carrying 8,000 pounds of explosives destined for German cities and factories. Where had they all come from? 3 months earlier, Steinhoff's unit had participated in Operation Bodenplatte, the Luftwaffe's desperate New Year's Day offensive that destroyed hundreds of Allied aircraft on the ground. Operational success, strategic irrelevance. Within weeks, the Allies had replaced every loss. The American bombers kept coming. The American fighters kept coming. No matter how many German pilots shot down, no matter how effective the tactics, no matter how brave the sacrifice, there were always more American aircraft. The veterans whispered that fighting the Americans was like trying to stop an ocean with a bucket. You could destroy everything in front of you, and the tide simply kept rising. Through his radio, Steinhoff heard the attack coordinations from other Luftwaffe units converging on the formation. Perhaps 200 German fighters total against this aerial armada. His tactical training said the bombers were vulnerable, that concentrated attacks could break formations, that determined fighter pilots could inflict unacceptable losses. His lived experience over 3 years of war told a different truth. The Americans accepted losses that would ground any other air force. They flew missions that German command would cancel as suicidal. And they returned tomorrow with fresh aircraft crewed by young men who had trained for months in America, while fuel shortages had reduced German pilot training to barely enough hours to take off and land. Steinhoff knew his duty. He would attack. His pilots would fight with the skill and courage that had made the Luftwaffe legendary. Some bombers would fall. Some would burn. The survivors would continue to target, release their bombs, and return to England where replacement aircraft waited for tomorrow's mission. And tomorrow, Steinhoff would scramble again with whatever fighters remained operational, facing another endless stream of American aircraft built in factories that German intelligence had dismissed as incapable of precision manufacturing. The cognitive dissonance was crushing. German aeronautical engineers were the finest in the world. German aircraft designs were sophisticated and advanced. German pilots were experienced and skilled. None of it mattered because the Americans had done something that violated every assumption German aviation industry carried about aircraft production. They had built an industrial system that produced aircraft faster than the Luftwaffe could destroy them. Not better aircraft, not more sophisticated aircraft. Just more aircraft, endlessly more, overwhelming more. As Steinhoff adjusted his oxygen mask and prepared to lead his fighters into attacking range, he understood with sudden clarity what German command refused to acknowledge. The war had been lost not in the air over Germany, not in the tactical engagements where German pilots still often prevailed, but in the factories of America, where methods German engineers had mocked as crude were producing the weapons that would destroy everything Germany had built. The Americans hadn't out-engineered Germany. They had out-manufactured Germany so completely that German engineering excellence had become strategically irrelevant. He armed his weapons and dove toward the bombers, knowing that the mathematics made the outcome inevitable regardless of how many Americans he killed today. The numbers behind Steinhoff's despair told a story that German leadership had refused to believe until it was far too late. By May 1944, American factories were producing over 9,000 aircraft per month. In that single month, American production exceeded Germany's total aircraft output for many entire years of the war. The facilities that German intelligence had dismissed as automobile factories unsuited for precision engineering were delivering complete heavy bombers at rates measured in hours, not months. Willow Run alone, Ford Motor Company's aircraft plant outside Detroit, was completing one B-24 Liberator bomber every 63 minutes around the clock. The transformation had required just 5 years. 5 years from a nation with almost no military aviation industry to a production colossus that built more aircraft than all of Europe combined. 5 years from skeptical German dismissal of American crude methods to industrial dominance so complete that Luftwaffe pilots like Steinhoff faced skies darkened by American aircraft they could never hope to defeat through tactical excellence alone. The total accounting was even more devastating. From 1940 to 1945, American factories would produce 324,750 aircraft of all types. Germany, which began the war with the most advanced aviation industry in the world and maintained sophisticated design capabilities throughout the conflict, would produce approximately 119,000 aircraft in the same period. Britain would build 131,549. The Soviet Union, 157,261. The Americans alone outproduced the entire Axis alliance. They did it using manufacturing philosophies that German engineers had studied before the war and rejected as fundamentally incompatible with aircraft construction. But the roots of this industrial revolution, the decisions and innovations that would fill German skies with endless American aircraft, had begun long before the war. The seeds of German defeat through American industrial supremacy were planted not in combat over Europe, but in the automobile factories of Detroit and in the philosophical clash between craft manufacturing and mass production that would determine which nation's approach to industrial warfare would prevail. September 1938, Dessau, Germany, Junkers Aircraft Factory. Ernst Udet, director of the technical office of the Reich Ministry of Aviation and a celebrated fighter ace from the Great War, led a delegation of American aviation industry representatives through one of Germany's most advanced aircraft manufacturing facilities. The Americans had come to study German production methods as relations between the nations deteriorated and war seemed increasingly possible. What they witnessed represented the pinnacle of traditional aircraft manufacturing. Master craftsmen fabricating components with precision tooling, skilled workers hand-fitting parts during assembly, small batches of aircraft moving through production with meticulous attention to quality. Among the American visitors was Charles Sorensen, production chief at Ford Motor Company, and the man who had designed the moving assembly line that revolutionized automobile manufacturing. Sorensen examined the Junkers facility with growing incredulity. What he saw was magnificent craftsmanship applied with extraordinary inefficiency. Aircraft were built essentially as individual custom products, each one slightly different, requiring skilled workers to compensate for variations during assembly. Sorensen's private assessment, recorded in notes he made during the visit, captured the fundamental philosophical divide. The Germans build aircraft the way medieval guilds built cathedrals. Every aircraft is a masterpiece of skilled craftsmanship. They employ workers who spent years learning their trades. The precision is extraordinary. The production rate is catastrophic. They will never be able to build aircraft in quantities sufficient for modern war using these methods. But they are so proud of their engineering tradition that they cannot imagine any other approach. Udet, for his part, was equally dismissive of American methods when the conversation turned to mass production. The Americans described their automobile assembly lines where semi-skilled workers performed simple, repetitive tasks on products moving continuously through sequential workstations. Udet's response, recorded by several witnesses, revealed the confidence that would prove Germany's undoing. Aircraft are not automobiles. They cannot be built by farm boys and housewives with a few weeks' training. They require precision engineering and skilled craftsmanship. Your American methods work for simple products where quality tolerances are loose. They will never work for combat aircraft where everything must be perfect. We have the finest aeronautical engineers in the world. We have skilled craftsmen whose expertise comes from generations of tradition. We have nothing to learn from automobile factories. This conviction ran deep through German aviation industry. The major manufacturers, Messerschmitt, Heinkel, Focke-Wulf, Junkers, Dornier, competed fiercely for design contracts and operated semi-independently with minimal coordination. Each factory maintained its own production methods, tooling standards, and quality control procedures. The system produced excellent aircraft, but was fundamentally incapable of rapid expansion because it depended on skilled workers who required years to train and could not easily be replaced. The American aviation industry in 1938 was tiny by comparison. Total production that year was under 4,000 aircraft, most of them civilian models. American military aircraft were generally inferior to German designs in performance. The Army Air Corps operated obsolescent bombers and fighters that couldn't match German combat aircraft in speed, armament, or operational capability. German technical assessments concluded that American aviation industry was backward and that American aircraft designs lagged behind European standards by 5 years or more. What German analysts missed was that American industry possessed something more valuable than current technical superiority: the philosophical framework and industrial infrastructure to achieve mass production at scales that German craft-based manufacturing could never match. The automobile industry had already demonstrated this capability. Ford alone had built over 15 million Model Ts using assembly line methods. General Motors produced millions of vehicles annually across multiple brands. American industry understood mass production in ways that European manufacturers, still largely operating on craft principles, did not. The question was whether these automobile production methods could be applied to aircraft, products far more complex than cars, and traditionally requiring skilled craftsmanship that American industry was thought to lack. German engineers were certain the answer was no. American production executives suspected the answer was yes, but they would need a crisis to prove it. The crisis arrived on September 1, 1939, when German forces invaded Poland and began the war that would test which industrial philosophy, craft manufacturing or mass production, would prevail in modern warfare. Over the next 6 years, that test would be conducted in the skies over Europe, and the results would be written in production statistics that German planners had considered impossible, and American factories would prove were merely the beginning of what industrial democracy could achieve when properly organized and challenged to attempt what traditional wisdom claimed could not be done. Segment 1. The philosophy of interchangeability. The fundamental difference between German and American manufacturing philosophy became visible not in factories but in maintenance depots and repair facilities across the combat theaters. German aircraft, built by skilled craftsmen who hand-fitted components, required skilled mechanics to repair. American aircraft, built on assembly lines with truly interchangeable parts, could be maintained by mechanics with minimal training using standardized replacement components. Lieutenant James Dooley, a maintenance officer with the 8th Air Force stationed in England, described the revelation in a letter home dated March 1943. "We received a damaged B-17 yesterday with the entire left wing destroyed by flak. The depot shipped us a replacement wing manufactured at a completely different factory than the original aircraft. We bolted it on using standard hardware. No fitting required, no modifications needed. It just fit perfectly." The old crew chiefs who learned their trade on civilian aircraft couldn't believe it. In the civilian aviation world, components always require some fitting and adjustment. These parts were truly interchangeable. The aircraft flew the next day. This interchangeability was no accident. It was the result of a philosophical commitment to precision at the manufacturing stage that eliminated the need for skilled fitting during assembly. American factories invested heavily in precision tooling and gauges that ensured every component met exact specifications. German factories relied on skilled craftsmen to compensate for variations during assembly. The American approach required massive upfront investment in tooling, but enabled rapid production by semi-skilled workers. The German approach required minimal tooling investment, but depended on skilled workers who took years to train. The strategic implications were profound. American factories could expand production rapidly by hiring and training new workers in weeks. German factories could not expand because skilled craftsmen could not be created quickly. When Allied bombing campaigns began destroying German aircraft factories in 1943 and 1944, the loss of skilled workers proved as devastating as the loss of facilities. America could replace destroyed factories and their workforces within months. Germany could rebuild facilities but could not replace the craftsmen who had died or been reassigned. Kurt Tank, chief designer at Focke-Wulf, visited a captured American aircraft factory in France after the Allied invasion and filed a report that revealed his shocked recognition of what German industry had missed. "The Americans have achieved true interchangeability at a scale we never imagined possible. Every component is manufactured to tolerances so precise that assembly requires no skilled fitting. This is not crude manufacturing. This is sophisticated manufacturing that enables crude assembly. We confuse the two. Our craftsmen perform sophisticated work during assembly because our manufacturing is not precise enough to eliminate that need. The Americans perform sophisticated work during manufacturing so that assembly can be simple. Their philosophy is superior for mass production." Segment 2. The Willow Run Revolution. The facility that would prove American mass production philosophy could revolutionize aircraft manufacturing rose from Michigan farmland between April 1941 and May 1942. Willow Run, Ford Motor Company's aircraft production plant, was designed from inception as an assembly line for bombers. The building itself was an engineering marvel. 3,500 feet long, 1,280 feet wide, covering 67 acres under one roof. It was the largest room in the world, specifically designed for continuous flow production of B-24 Liberator bombers. Charles Sorensen, Ford's production chief who designed Willow Run's production system, faced skepticism from every direction. Aircraft manufacturers insisted that bombers could not be built on assembly lines. Military officials worried that Ford lacked aviation expertise. Labor leaders doubted that automobile workers could build combat aircraft. Sorensen's response was to treat the B-24 as an engineering problem that required systematic solution, rather than as a mystical product that required craftsman's touch. The first challenge was design for production. The B-24, as originally designed by Consolidated Aircraft, contained hundreds of components that required hand-fitting during assembly. Ford engineers redesigned these components for true interchangeability, creating over 15,000 specialized tools, jigs, and fixtures that positioned parts automatically and ensured correct assembly. Workers didn't need to understand aircraft design. The tooling made it physically impossible to assemble components incorrectly. The second challenge was workforce development. Willow Run would eventually employ 42,000 workers, most with zero aircraft experience. Ford created training programs that taught specific tasks rather than general aircraft construction skills. A worker might spend 3 weeks learning to install the hydraulic systems in the B-24's bomb bay, then perform that same task repeatedly on every aircraft moving down the line. The repetition built speed and quality simultaneously. Rosie Will Monroe, a 23-year-old widow from Kentucky who had worked as a waitress before the war, became one of Willow Run's most productive riveters and the inspiration for Norman Rockwell's famous Rosie the Riveter poster. Her account of the training process revealed the system's power. "They showed me how to drive rivets along the wing panel seams. That's all. Not how aircraft fly, not how wings work, just how to drive these specific rivets in this specific sequence. After the first week, I could do it in my sleep. After the first month, I was training new girls. I never understood the whole aircraft. I just knew that if I did my rivets right and everyone else did their jobs right, a bomber came out the other end that would fly to Germany and bomb the hell out of Hitler." The production ramp-up was slower than Sorensen had promised. The first B-24 emerged from Willow Run in September 1942, nearly 4 months behind schedule. It required extensive rework before it could fly. Aircraft manufacturers pointed to these problems as proof that assembly line methods didn't work for complex products. They missed the essential point. The system was being debugged exactly like Ford had debugged Model T production, systematically eliminating problems through engineering discipline. By December 1942, Willow Run produced 56 B-24s. By June 1943, 190 monthly. By December 1943, 365 monthly. By August 1944, the plant peaked at 432 bombers for the month, averaging 1 complete B-24 every 63 minutes around the clock. The facility that skeptics had predicted would fail was producing more bombers monthly than Germany's entire aviation industry produced in some quarters. The human achievement was as significant as the industrial one. The workforce at Willow Run included thousands of women, African Americans in their first major industrial employment, and workers from backgrounds that traditional aircraft manufacturers would never have considered. They proved that complex manufacturing could be performed by people given proper training and proper systems, that excellence in production came from systematic engineering rather than mystical craftsmanship. Segment 3. German Intelligence. Failures. Throughout 1941 and 1942, German military intelligence received reports of American aircraft production expansion that should have triggered strategic alarm. The reports were systematically dismissed as propaganda, the numbers considered impossible, the claims of assembly line bomber production treated as American exaggeration designed to intimidate. Oberst Joseph Beppo Schmid, chief of Luftwaffe intelligence, filed assessments in late 1942 that captured German leadership's refusal to accept evidence that contradicted their assumptions. American claims of producing thousands of aircraft monthly are propaganda. Their aviation industry lacks skilled workers necessary for quality aircraft construction. Reports of assembly line bomber production are technically absurd. We assess actual American production at approximately 2,000 to 3,000 aircraft monthly, mostly inferior training aircraft, and transports. American combat aircraft quality remains below German standards. We anticipate no significant threat from American air power before 1944 at earliest. Every assumption in this assessment was catastrophically wrong. By the time Schmid filed this report, American factories were already producing over 4,000 aircraft monthly, and the production curve was accelerating steeply. Willow Run alone would soon exceed his estimates for all of American aviation industry. The intelligence failure was not due to lack of information, but to refusal to believe information that contradicted German expectations. The few German observers who recognized the truth were ignored or dismissed. After visiting neutral Sweden in early 1943, Luftwaffe Major Hajo Hermann filed a report based on Swedish intelligence sources that accessed American production data. American aircraft production has exceeded 6,000 aircraft monthly and continues accelerating. The Willow Run facility is producing B-24 bombers at rates that match our entire fighter production. We face industrial capacity of an entirely different order than we planned for. Our production expansion plans are inadequate by factors of 5 or 10. This represents existential strategic threat. Hermann's report was classified and suppressed. Göring, commander of the Luftwaffe, refused to present it to Hitler. The few officers who saw it assumed the numbers were errors or misunderstood. The alternative, that American crude methods were producing aircraft at rates that made German production irrelevant, was simply too threatening to German self-conception to be accepted. By 1944, when the evidence became impossible to deny, the psychological impact on German leadership was devastating. Albert Speer, Minister of Armaments and War Production, recorded in his diary after receiving accurate American production statistics. "We have lost the war in Detroit. Every strategic calculation we made assumed rough parity in industrial capacity. The Americans have industrial capacity that exceeds Germany, Britain, and Russia combined. Their aircraft production alone is larger than our total weapons production across all categories. We cannot win a war of attrition against such disparity. Every tactical victory is strategically meaningless when the enemy replaces losses faster than we can inflict them." Segment 4. The Training Revolution. The transformation of American workers from civilians to aircraft producers required systematic training programs that revolutionized industrial education. Traditional aircraft manufacturing relied on apprenticeship systems where workers learned over years under master craftsmen. American mass production required training programs that produced competent workers in weeks. The training philosophy was radical. Workers didn't need to understand the entire aircraft or even their entire subassembly. They needed to perform specific tasks repeatedly with speed and precision. The training focused on procedural knowledge rather than conceptual understanding. A worker installing electrical systems in the B-17's nose section didn't need to understand electrical theory. They needed to know which wires connected to which terminals in which sequence, and they needed to be able to do it quickly without errors. Jack Northrop, founder of Northrop Aircraft Corporation, initially opposed this approach before adopting it under pressure from military production demands. His conversion was captured in a memo to senior engineers dated October 1942. "I was wrong about worker training. I insisted we needed skilled craftsmen. We don't. We need systematic processes and adequate training for those processes. I watched a worker yesterday who had been a grocery clerk 6 weeks earlier. She was installing wing fuel tanks in P-61 night fighters with speed and precision that matched our most experienced mechanics. The difference is that she does this one task repeatedly, while experienced mechanics must remember hundreds of different tasks. The repetition creates excellence. The system ensures quality. My craft-based assumptions were obsolete. The scale of training was unprecedented. By 1943, American aircraft factories were hiring and training over 100,000 new workers monthly. Training centers operated around the clock. The programs were designed by industrial psychologists and efficiency experts who studied every task, broke it into learnable steps, and created training protocols that minimized the time from hiring to productivity. The results proved that craft skills, while valuable, were not necessary for quality production when systematic engineering eliminated the need for skilled fitting and adjustment. American aircraft were not crude products built by unskilled workers. They were sophisticated products built by workers trained to perform specific tasks within engineered systems that ensured quality. Segment 5. The Mathematics of Attrition. By mid-1943, The mathematical reality of industrial warfare had become undeniable to Luftwaffe commanders, even as German political leadership refused to acknowledge it. Every combat engagement revealed the same brutal arithmetic. German fighters achieved tactically impressive results that were strategically meaningless because American losses were immediately replaced, while German losses accumulated irreversibly. Major Gunther Rohl, who would survive the war as the third highest-scoring fighter ace in history, with 275 victories, described the psychological impact in post-war interviews. By 1943, every experienced pilot understood we were fighting an unwinnable war of attrition. We might shoot down 3 bombers and 2 fighters in a mission. Excellent results by any measure. But intelligence reported 3 new bomber groups arriving in England that week. We lost 2 experienced pilots who took years to train. They were replaced by novices with barely enough flight hours to take off and land safely. The Americans lost aircraft and crews, but replaced both within weeks with equal or better equipment and adequately trained replacements. We were being ground down by an enemy who could afford losses that would have crippled any previous air force. The kill ratios that should have ensured German victory instead revealed the impossibility of defeating American industrial capacity through tactical excellence. In the terrible fighting over Germany in early 1944, Luftwaffe fighters achieved kill ratios approaching 4:1 in some engagements. 4 American aircraft destroyed for every German fighter lost. In previous wars, such ratios guaranteed victory. Against American production, they merely delayed defeat. The 8th Air Force, operating heavy bombers from Britain, lost approximately 4,700 B-17s and B-24s destroyed or damaged beyond repair during the strategic bombing campaign. These losses represented catastrophic casualties, roughly 40,000 American airmen killed, wounded, or captured. For Germany, such losses would have ended the bombing campaign and forced a fundamental reassessment of strategy. For America, the losses were acceptable because replacement aircraft and crews were already in the pipeline. American production made tactics that would be suicidal for other nations strategically sound. The Schweinfurt-Regensburg mission on August 17, 1943, saw 60 of 376 bombers lost, a 16% loss rate that would have been unacceptable for any force operating with German production constraints. The 8th Air Force absorbed the losses, implemented tactical changes, and continued operations at increased intensity. Within weeks, bomber strength exceeded pre-mission levels because Willow Run and other factories were producing replacements faster than the Luftwaffe could shoot them down. Adolf Galland, general of the fighter arm and one of Germany's most respected aviation leaders, captured the despair in a November 1943 report to Göring. "We are achieving the impossible, and it changes nothing. Our pilots are performing beyond what any reasonable commander could expect. Our fighters are technically competitive. Our tactics are sound. We are losing because the enemy has industrial capacity that makes our tactical victories strategically irrelevant. We shoot down 100 bombers. 200 more appear. We destroy American fighter groups. New groups arrive from America within weeks. We cannot kill them faster than Detroit can build their aircraft. This is not warfare. This is industrial execution." Segment 6. Design Philosophy, Performance vs. Producibility. The contrast between German and American aircraft design philosophy revealed itself not in technical specifications, but in production numbers. German designers optimized for performance, creating aircraft with capabilities that often exceeded American equivalents. American designers optimized for producibility, creating aircraft that could be manufactured in quantities that made performance advantages irrelevant. The Focke-Wulf Tu-152, Kurt Tank's ultimate high-altitude fighter, exemplified German philosophy. It featured advanced aerodynamics, a powerful Junkers Jumo 213 engine, heavy armament, and performance that exceeded any Allied fighter at high altitude. It was also extraordinarily complex, requiring approximately 2,000 man-hours to build using German production methods. Focke-Wulf produced fewer than 150 TR-152s before war's end. A magnificent aircraft, strategically meaningless. The Republic P-47 Thunderbolt exemplified American philosophy. It was designed from the start for mass production using available engines, standard components, and manufacturing techniques that could be distributed across multiple factories. It required approximately 800 man-hours to build using American assembly line methods. Republic and its subcontractors produced over 15,000 P-47s. The aircraft was adequate rather than exceptional in most performance categories. 15,000 adequate fighters overwhelmed 150 exceptional ones. The design review process revealed the philosophical divide. German aircraft designers presented performance specifications to engineers who then designed aircraft to meet those requirements. Producibility was a secondary consideration addressed after the design was finalized. American designers worked with production engineers from initial concept, ensuring that every design choice considered manufacturing implications. Performance was important, but only if it could be achieved in producible designs. Clarence Kelly Johnson, chief engineer at Lockheed Aircraft Corporation, explained the American philosophy in a wartime memo to his design team. "We are not trying to create the best fighter in the world. We are trying to create a fighter that is good enough to win and that we can build in quantities sufficient to achieve air superiority through numerical advantage. A fighter that is 20% better than the enemy's, but that we can only build in small numbers, loses to a fighter that is 10% worse, but that we can build in large numbers. The mathematics of warfare reward adequate equipment produced abundantly over excellent equipment produced rarely." This philosophy was applied systematically across American aviation industry. The B-24 Liberator was inferior to the B-17 Flying Fortress in crew comfort, defensive armament, and operational ceiling. But the B-24 was easier to build using assembly line methods. Ford chose the B-24 for Willow Run, specifically because its design was more compatible with mass production. The result was that B-24 production exceeded B-17 production, despite the B-17 being the more famous and arguably superior bomber. German designers, constrained by craft manufacturing philosophy, could not make the same choices. They created sophisticated designs that German industry could not build in relevant quantities. The Messerschmitt May 262 jet fighter was the most advanced fighter of the war. Germany produced approximately 2,400 before surrender. If German industry had instead focused on producing simplified conventional fighters using mass production methods, they might have built 5,000 or more aircraft with the same resources. Still inadequate against American numbers, but more militarily useful than having 1,400 jets. Segment 7. The Crisis of Skilled Labor. The dependence on skilled craftsmen that defined German aircraft manufacturing became an existential vulnerability when Allied bombing campaigns began targeting German cities and factories. Every raid that killed skilled workers or destroyed worker housing inflicted damage that could not be quickly repaired. Facilities could be rebuilt in months. Skilled craftsmen required years to train and could not be replaced. By 1944, German aviation industry faced cascading skilled labor crises that no amount of factory construction could solve. Albert Speer's ministry issued directives requiring aircraft manufacturers to simplify designs and reduce dependence on skilled labor. The directives were largely ignored because German factories lacked the precision tooling and systematic processes that would enable unskilled workers to produce quality components. American industry faced no equivalent crisis. The loss of factories to fire, accident, or sabotage had minimal long-term impact because the workforce was semi-skilled and easily replaced through standardized training programs. A factory destroyed could be rebuilt and restaffed to full production within months because the workers who had been employed there were performing tasks that required weeks of training rather than years of apprenticeship. The contrast became visible in production statistics as the war progressed. German aircraft production peaked in 1944 at approximately 39,000 aircraft, despite desperate expansion efforts and the mobilization of concentration camp labor. The ceiling was not physical capacity, but skilled labor availability. American production peaked in 1944 at 96,318 aircraft and could have been sustained or expanded if military requirements had demanded it. The ceiling was not labor availability, but strategic necessity. There were only so many aircraft needed to achieve complete air superiority. Heinrich Lübbe, production manager at Messerschmitt's Regensburg facility, described the skilled labor crisis in a report to company leadership in March 1944. "We have lost 35% of our skilled workers to bombing, military conscription, and attrition over the past year. Training replacement workers to equivalent skill levels would require 2 to 3 years under normal circumstances. We do not have 2 to 3 years. We are attempting to maintain production using partially trained workers, elderly retirees, and forced laborers. Quality is suffering. Production rates are declining. We cannot build aircraft as fast as we are losing the skilled workers who know how to build them. The Americans do not face this problem because they never depended on skilled workers in the first place." Segment 8. The Supply Chain Revolution. American mass production of aircraft required revolutionary changes to supply chain management that German industry never attempted. Building one B-24 every hour at Willow Run required coordinating delivery of 1.55 million parts from hundreds of suppliers with precision that matched automobile production standards. The logistics of this coordination represented an industrial achievement as significant as the assembly line itself. Traditional aircraft manufacturing used small batch supply chains where components were ordered in quantities of dozens or hundreds and arrived over weeks or months. American mass production required continuous flow of components arriving in quantities of thousands and synchronized to assembly line demand. A single missing component could halt production of dozens of aircraft. The solution was systematic supplier development programs that transformed American industrial practice. Ford and other major aircraft manufacturers sent engineers to suppliers to redesign components for mass production, invested in supplier tooling, and created quality control systems that ensured components met specifications without requiring inspection and rework. The suppliers became extensions of the assembly line, producing components in continuous flow that matched production demand. The scale was unprecedented. Willow Run alone required coordinating over 500 suppliers, delivering components ranging from engines and propellers to rivets and electrical connectors. Every supplier had to maintain production schedules that matched Willow Run's assembly line speed. A delay of even a few hours from a critical supplier could shut down bomber production that cost thousands of dollars per minute in lost output. The coordination was achieved through systematic logistics management that used telephone and teletype networks to track production and shipping in near real time. This was revolutionary for 1940s industry and represented capabilities that European manufacturers would not develop until decades after the war. The logistics infrastructure that enabled mass aircraft production became the foundation for post-war American supply chain management practices that transformed global manufacturing. Segment 9. Quality through systems. German engineers insisted throughout the war that American mass production necessarily produced inferior quality. This claim was disproven by operational experience that showed American aircraft met or exceeded German quality standards while being produced at rates that German craft methods could never achieve. The secret was that American production achieved quality through systematic engineering rather than through skilled workers compensating for manufacturing variations. The precision tooling, standardized processes, and systematic quality control created consistency that craft manufacturing could not match. Every B-24 from Willow Run was built to the same specifications using the same processes. Variations between aircraft were minimal. German aircraft, built by craftsmen who hand-fitted components, exhibited significant variations between individual aircraft that affected maintenance and operational effectiveness. Colonel Bernalay Jr., a B-17 pilot and author who flew combat missions over Germany, described the American quality advantage in a post-war article. "We flew bombers built by workers who had been civilians months earlier. These supposedly crude aircraft flew through conditions that would destroy lesser machines. We took catastrophic battle damage that should have been fatal and made it back to England because the structural design included massive safety margins and the manufacturing quality ensured everything worked as designed. The Germans flew aircraft built by master craftsmen, and their aircraft were excellent. Ours were produced by systematic processes, and they were equally excellent while being produced in quantities the Germans could never match. Quality through systems defeated quality through craftsmanship." The maintenance experience confirmed this assessment. American aircraft could be maintained by mechanics with minimal training using standardized procedures and interchangeable parts. German aircraft required skilled mechanics who understood the specific variations of individual aircraft and could fabricate custom repairs when standard parts did not fit. The American approach enabled forward maintenance under combat conditions. The German approach required extensive depot-level maintenance that reduced aircraft availability. Segment 10. The Psychological Collapse. By 1945, the psychological impact on German aviation industry of watching American production overwhelm German technical excellence had become as significant as the material defeat. Engineers and managers who had spent careers believing in German engineering superiority confronted evidence that their fundamental assumptions about aircraft manufacturing were obsolete. Kurt Tank's final report to German aviation authorities, written in March 1945 as American forces approached his facilities, captured the complete intellectual collapse. "We have been defeated not by superior enemy aircraft, but by superior enemy production philosophy. We created magnificent aircraft that we could not build in sufficient numbers. They created adequate aircraft that they built in overwhelming numbers. We optimized for excellence. They optimized for victory. We were craftsmen in an industrial war. They were industrialists who understood that warfare at this scale requires treating weapons as products rather than as art. Our traditions, our pride in engineering excellence, our conviction that quality would triumph over quantity, all of these were liabilities in a conflict where industrial capacity determined outcomes. We lost because we refused to learn from the e.g. Americans. We dismissed their methods as crude when they were actually sophisticated in ways we never understood. The factory tours that German engineers took of captured American facilities after the war completed the psychological transformation. Watching B-24s emerge from Willow Run at hourly intervals, seeing the systematic processes and precision tooling, understanding the training programs and supply chain coordination, German engineers confronted physical evidence that everything they had believed about aircraft manufacturing was wrong. Ernst Heinkel, who had dismissed American methods as barbaric in 1939, toured American facilities in 1946 and recorded his reassessment. "I was arrogant. We all were. We believed German engineering tradition guaranteed superiority and that American methods were appropriate only for simple products. We were catastrophically wrong. The Americans revolutionized aircraft manufacturing using principles that will define industrial production for generations. Their methods were not crude. Their approach was not barbaric. They were visionaries, and we were dinosaurs who could not adapt until we were extinct." Conclusion: the victory sealed in Detroit. The final reckoning of the industrial war for air supremacy was written not in the tactical engagements over Germany, but in production statistics that told a story of complete industrial dominance. From 1940 to 1945, American factories produced 324,750 aircraft. Germany produced approximately 119,000. Britain produced 131,549. The Soviet Union produced 157,261. The Americans alone, starting from minimal military aviation industry in 1939, outproduced Germany, Japan, and Italy combined. They did it using methods that German engineers had dismissed as crude, with workers German industry considered unqualified, and with design philosophies German tradition rejected as inappropriate for precision engineering. The mathematical inevitability that Oberst Johannes Steinhoff confronted on May 26, 1944, watching 200 American bombers and 800 fighters darken German skies, had been sealed years earlier in the automobile factories of Detroit, when American industry committed to applying mass production philosophy to aircraft manufacturing. The Germans had won every technical argument about aircraft design excellence. They had created sophisticated fighters and bombers that often exceeded American equivalents in performance. None of it mattered because they had lost the fundamental strategic argument about how to organize industrial production for total war. The victory was sealed not when American fighters achieved air superiority over Germany, not when bombers destroyed German industrial capacity, not when the Luftwaffe collapsed from irreplaceable losses. The victory was sealed in September 1942 when the first B-24 emerged from Willow Run's assembly line, proving that bombers could be mass-produced using automobile methods. Everything after was mathematical consequence. If bombers could be built at automotive production rates, then no nation relying on craft manufacturing could produce sufficient aircraft to achieve air superiority against American numbers. Charles Sorensen, the Ford production chief who designed Willow Run and proved that aircraft were just complicated automobiles, summarized the revolution in his final report to Henry Ford as bomber production wound down in 1945. We demonstrated that complex products previously requiring craft manufacturing can be mass-produced using systematic methods. We proved that adequate training enables ordinary workers to achieve extraordinary productivity. We showed that design for manufacturability enables production volumes that transform strategic possibility. The Germans built magnificent aircraft. We built an air force that darkened their skies. Their engineers were brilliant. Our system was superior. Individual excellence cannot defeat industrial democracy properly organized. The strategic implications extended far beyond the immediate military victory. American mass production methods that proved themselves producing aircraft during the war became the foundation for post-war American industrial dominance across multiple sectors. The systematic training programs developed to turn civilians into aircraft workers in weeks became models for post-war industrial education. The supply chain management systems created to coordinate hundreds of suppliers for continuous flow production became standard practice in American manufacturing. The design philosophy that prioritized producibility over pure performance became embedded in American engineering culture. The human legacy proved equally significant. The women who had riveted wings at Willow Run and assembled fuselages at Douglas and Boeing carried their industrial experience into post-war careers, breaking gender barriers across American manufacturing. The African Americans who had been hired into previously segregated aviation jobs used their wartime experience to challenge discrimination in post-war employment. The veterans who returned from operating and maintaining mass-produced aircraft entered civilian life with technical skills that enabled America's post-war economic expansion. The workers themselves understood what they had accomplished. Rosie Will Monroe, the waitress who became a riveter and a symbol of American industrial mobilization, reflected decades later on her Willow Run experience. "We didn't know we were making history. We just knew we were building bombers to win a war. But looking back, we proved something important. We proved that ordinary people, given the right training and the right systems, can accomplish extraordinary things. The Germans had craftsmen with decades of experience. We were farm girls and housewives and kids fresh out of high school. We built more aircraft in a few years than they built in a decade. Not because we were better workers, but because we had better systems. That's the real lesson. Excellence comes from systematic engineering, not from mystical craftsmanship. The German engineers who survived and later examined American aviation facilities acknowledged truths that their wartime leaders had refused to accept. Willy Messerschmitt, creator of the Bf-109 and Me-262, visited American factories in the 1950s and provided an assessment that captured the complete inversion of pre-war expectations. We lost the war in Detroit before the first shot was fired. American industrial philosophy enabled production capacity we never imagined possible. We designed aircraft as if we had unlimited time and resources. They designed aircraft knowing time and resources were constraints that systematic methods could overcome. Their approach was not crude, it was revolutionary. We failed to see the revolution until it destroyed us. The Americans didn't just outproduce us. They revolutionized what was possible in industrial warfare. That revolution continues to shape manufacturing worldwide decades after the war. The enduring legacy of American aircraft mass production extends into every aspect of modern aerospace manufacturing and beyond. Commercial aviation exists in its current form because Boeing and Douglas and Lockheed learned during the war how to produce aircraft at scales that made air travel economically viable for millions. The systematic processes, the emphasis on interchangeability, the design for producibility, the training programs that turn civilians into skilled workers in weeks rather than years, all of these principles, pioneered during wartime aircraft production, became standard practice across global manufacturing. The philosophical transformation proved more significant than any individual technological achievement. Before the war, aircraft manufacturing was viewed as a craft requiring traditional methods and skilled artisans. After the war, aircraft manufacturing was understood as an industrial process requiring systematic engineering and organized production. This transformation influenced how industries approached manufacturing challenges across sectors from automobiles to consumer electronics to construction. The strategic lesson remains relevant wherever industrial capacity determines competitive outcomes. The side that optimizes for production volume and systematic efficiency defeats the side that optimizes for individual product excellence when both sides are producing adequate products. German aircraft were often technically superior to American equivalents in specific performance metrics. American aircraft were strategically superior because they existed in quantities that made German performance advantages irrelevant. 10 adequate fighters defeat 3 excellent ones. 1,000 adequate bombers accomplish what 100 excellent bombers cannot. Kurt Tank's final assessment, written decades after the war as he reflected on his career, designing some of the finest aircraft ever built, captured the lesson with painful clarity. Excellence in design cannot overcome excellence in production. Individual brilliance cannot defeat systematic capability. We learned this at terrible cost. The Americans taught us that modern war is won in factories before it is fought on battlefields. Their crude methods weren't crude. They were the future. We were the past, trapped in tradition, blinded by pride, defeated by our failure to understand that the world had changed and that victory would go to whoever could build the most, not whoever could build the best. I'm proud of the FW-190. It was one of the finest fighters ever designed. But it changed nothing because we could not build enough of them. The Americans built 15,000 P-47 Thunderbolts using assembly line methods. Adequate aircraft produced in overwhelming numbers. That is what won the air war. That is what won the entire war. The statistical reality tells the complete story with brutal finality. In March 1944, American factories produced 9,113 aircraft in a single month. Germany's total production for many entire years of the war failed to match that single month of American output. Willow Run alone produced 8,185 B-24 bombers, more than many nations produced of all aircraft types during the entire war. The facility that skeptics predicted would fail became the symbol of what American industrial democracy could achieve when properly challenged. The production peak of 96,318 aircraft in 1944 represented industrial capacity that exceeded anything previously achieved in human history. It was sustained not by craftsmen with decades of experience, but by systematically trained workers performing specialized tasks in engineered production systems. It proved conclusively that complex products could be mass-produced at automotive scales using philosophies that traditional manufacturing dismissed as inappropriate for precision engineering. The Germans had laughed at American crude manufacturing in 1938 when Charles Sorensen toured their facilities. They had dismissed American plans for mass aircraft production as propaganda in 1941. They had insisted that assembly line methods could never produce quality aircraft. By 1945, Germany was occupied by forces whose crude methods had produced the air fleets that annihilated German resistance. The factories that German engineers considered appropriate only for automobiles had built the weapons that destroyed everything German precision engineering created. The sky above Germany that Oberst Steinhoff had seen darkened with American aircraft on May 26, 1944, remained filled with American aircraft for the rest of the war. Each mission brought bombers that destroyed German industrial capacity and fighters that swept German defenders from the sky. Each mission was enabled by production systems that German industry could not match and philosophical commitments that German tradition could not accept. The final accounting is absolute and unforgiving. Adequate equipment produced in overwhelming quantity defeated excellent equipment produced in insufficient numbers. Systematic engineering defeated craft tradition. Industrial democracy defeated technical aristocracy. The Americans proved that modern warfare at industrial scale requires optimizing for production rather than for performance. That victory goes to whoever can fill the sky with aircraft rather than whoever can build the best aircraft, and that the mathematics of industrial production determine strategic outcomes regardless of tactical excellence. The revolution built in Detroit conquered the skies over Europe one mass-produced aircraft at a time. The crude American methods that German engineers had scorned proved to be the most sophisticated industrial philosophy ever applied to warfare. The victory was complete, inevitable, and written in production statistics that told a simple story. 324 of 750 American aircraft overwhelmed 119,000 German aircraft. The numbers alone decided the war in the air and ensured Allied victory. German engineering excellence created magnificent aircraft that changed nothing. American systematic production created adequate aircraft that won everything. That lesson, demonstrated in the skies over Germany between 1942 and 1945, remains valid wherever industrial capacity determines competitive outcomes. The side that can build the most wins. The side that optimizes for excellence loses. Detroit taught that lesson to the world, and the world has never forgotten it. The crude methods weren't crude at all. They were the future, and the future belonged to whoever understood that victory in industrial warfare requires factories before fighters, production lines before performance, and systematic capability before individual excellence. The Americans understood. The Germans did not. That difference, more than any tactical decision or technical innovation, determined who would win the war in the air and ultimately who would win the war itself. The sky belonged to whoever could fill it with aircraft. Detroit filled it. That was enough. That was everything.